Good morning, good afternoon, good evening, wherever you are in the world. Thank you so much for joining us today. My name is Sarah Alspaugh, and I will be your webinar host coming to you from Cincinnati, Ohio, here in the U.S. I'd like to welcome you to today's webinar, our topic, Digital Machine Shop, Accelerate Production with Multiple Setup Machining. And I'd like to welcome and introduce our speaker today, Brian Draboblis. He is our channel enablement here at Siemens. You can see some of his expertise here on the screen, as well as some of the interesting projects that he has been involved with. I'm going to go ahead and turn things over now to Brian's presentation. And again, please put your questions in to the Q&A part at any time. All right, here we go.
Hello, and welcome to today's presentation. I'm here to discuss how you can gain the benefits from Siemens digital twin technology for your machine shop. Dealing with multiple parts and multiple setups for those parts then help you unlock your potential to streamline your programming with the full-featured CNC programming with NX CAM.
The machine shop of the future is here now. It's a data-driven manufacturing environment that seamlessly connects your process, machines, robots, equipment, and all the other elements of your operation. It's an adaptive manufacturing system that can sense, learn, and share that knowledge with every resource in its ecosystem, including people. At Siemens, we call this end-to-end interaction between the virtual and real worlds digitalization. That's how we're helping companies compete. Digitalization uses a digital twin to help you design the right product and discover the best way to make it. The digital twin is a precise virtual copy of both your real product as well as your manufacturing process and resources. We figured out the best way to seamlessly unite key elements from design through manufacturing and even actual use into a virtual model that performs like the physical equivalent. You reduce risk by ensuring every part is built on spec, on time, and on budget. You reduce bottlenecks and ensure process optimization. You take on more complex projects that would have previously been thought too risky or unprofitable. And finally, you increase flexibility with faster changes than ever before in any plant at any time. All of this to ensure you build the products your customers want, grow profits, and gain efficiency. At Siemens, we digitalize manufacturing so you can realize the machine shop of the future today.
Manufacturing happens in small shops. 90% of all U.S. manufacturing is done by small businesses. About 60% of U.S. metalworking is done in facilities with under 50 employees. These small businesses are driving a lot of advanced technologies and GDP. More than half of these machine shops use standalone CAD and CAM systems. The manufacturing data is controlled in only 1/3 of these companies, and 75% use completely disconnected CMM inspection processes. The most surprising discovery was that 61% of the machine shops still rely on paper to transfer data between planning and production. Clearly, this approach by manufacturers to use disconnected, partially automated, process-driven by separated technologies is no longer enough to be successful today. The main objective for a machine shop, regardless of the industry, is increasing throughput. That's one of the key competitive pressures. You can increase throughput by shortening machine cycles, faster setup, and reducing machine downtimes. Meeting the quality standards is critical. Consistently achieving high quality requires precise machining, better finish, and using the best practices to achieve repeatability. As you compete, you want to look at new technologies that will open up new business opportunities for you. But achieving these objectives is a challenge for many manufacturers. One of the main reasons are inefficient processes that they have in place, as shown in the results of the study that was recently conducted by the industry analyst. A 3D solid model is a digital twin of the product that you are manufacturing. It all starts with this smart model of the machine part. Now, let's see how the digital twin of the physical part can drive the entire manufacturing process. The 3D solid model can be read or designed in your CAD system. The digital twin of the part model is the input to the manufacturing process. Ideally, you want to work in the same software where you designed a 3D model and define the entire setup, including the fixture and other components, so that you have one consistent environment, and by using the same model definition, you can take advantage of the data into the CAM module for your NC programming to create and validate the G code to drive your machine tools. Creating associativity and complete shop documentation using the digital twin for that machining setup lets you drive efficient and flexible production processes. For example, if there's like a design change or you need to change a fixture, this update can be automatically replicated in the documentation all the way to the shop floor inside that one system without having to go to multiple systems, potentially re-importing that geometry and even in some cases starting over. In parallel, your quality team can work on defining the inspection process. Increasingly more companies are using their product manufacturing information, or PMI, attached to the model. The PMI data can include the tolerance and surface finish information. Traditionally, this information, you would have used drawings to re-input this into your CAM system for tolerance and surface finish information. And that would have all had to been done manually to enter that data into your system. By having it tied to the PMI data directly, NX can read that information and apply the appropriate machining practices to that particular feature to meet that tolerance or surface finish information. Today, using the latest software, the PMI can be added to the model definition during the designing of the part, and then use that data to automate the CNC programming, as we had talked about, but you can also automatically create inspection programs for your coordinate measuring machines. Here you can see the use of the consistent digital thread through the entire manufacturing process. With NX, you can use one model in a single software system to go from the part preparation right through programming and then down to production. The model-driven process is one of the key tenets of the digital machine shop that can give you the competitive advantages, including associativity to the supplied design data, concurrent workflow, and accuracy and reliability. Next, we will have a look at the model-driven process fueled by Siemens digital twin technology. Model preparation and job setup in NX. Here, you can import or design your CAD model. NX reads all common CAD formats. We're going to select the CATIA V5 format. It's just a Windows file open. And here we'll see as we convert and load the part directly into NX, seeing the CATIA model. From here, we're going to create a sketch plane and model the work holding and fixtures, creating the construction geometry that's used to build that fixture. We'll start with just a simple rectangle defining the outside border or the footprint or pad for the fixture. Again, with constraints and dimensions, you can size and shape the geometry as necessary. Here we're selecting the edges or features of the part that will be used to create the containment boundaries on the fixture. This ensures that the fixture will always be associative to the part geometry. You can create fully defined sketches using the CAD tools in NX, as here we're adding additional geometry defining our design. You can create geometric rules that also assist in your design. Here we'll make all these lines parallel to the other sides of the fixture. Modeling the base and the mounting plate of the fixture is simple. It's just in the context of the part. We just select the part, we'll select extrude, and we'll just pick a face onto the part. This would be the mating face where the fixture would align to the part. We'll then select the top area, creating the mounting plate for the part. From here, you can go ahead and add other fixture components to the part. Like here, we'll add a bolt, right, that will be used in our finished assembly fixture or our inspection fixture to do that. Again, you can add additional clamps and fixtures using assemblies and components. So here, we'll turn these off, and we'll continue on with our design using synchronous modeling to create the stock model for the manufacture of this part. Here we'll select the entire part and close all of the hole openings on the part. Again, we'll then offset different regions and boundaries of the part, representing what the casting stock would be from an investment cast part. Here we'll see a synchronous modeling can directly edit all the imported CAD model data. We'll add stock to the boss areas, change the blend radiuses on the part, and remove some of the other features or defeature the part into that. Add draft angles, etc., and continue modeling the stock model of the part. Here we will continue modeling the second fixture for the part. Again, a similar operation as the first, we'll just create our sketch for a part, defining the areas of the fixture we need to create. We'll select the edges of the geometry again to remain associative. There we select the geometry. You can see the ease of modeling with inside of NX to create the fixture. Here we will move some of the clamp components. You can again see the ease of the dynamic repositioning of components in NX. From there, we would create the fixture setup drawings for the shop floor. Again, this becomes a vital important when jobs are created is to have this kind of documentation quickly, easily, and readily available associated to the part. Preparing product manufacturing information with PMI, again, is easy just by attaching the geometry the same as you would in any sketches or dimensioning onto the part and creating the drawing, thus defining the product manufacturing information and feature control frames. Here we see the finished drawing being created for the inspection operations. There we move into and you see a finished job preparation has been completed. Design model, 2 fixtures, 2 stock models, in-process drawings, inspection drawings, etc. Accelerate your production with NX. Now that we had just seen an example of how to build associative fixtures, the documentation, and some preparation into the inspection or the quality department with CMM, next we shall take a look at the continuing of the process of programming the workpiece and preparing for output to the shop floor. Programming the setups and operations in NX. Adding the part and the fixture to the CMM from our previous model preparation is fast and easy. Simply open the part and add it to the machine tool. Dynamically adjust the fixture components. Here we will align the clamp to the mounting holes on our CMM. You may use constraints to center this clamp on the table hole position, just by selecting the edges of the clamp and a hole position. Using the PMI automation begins by linking the PMI on the model to the part. We select the STM 600 probe, and we automatically recognize the features, the measurement dimensions, and locations for the part. The inspection paths are also seen in the inspection navigator. We verify the inspection paths of our part with simulation. And to modify a path, we simply double-click to change any of the settings. Here we'll look at the point set and change them from 8 points to a 6x6 grid. Fast and easy programming in NX CMM. Let's look at what CNC programming department has been doing while we were over in inspection. First, set up programming the part and the fixture is mounted to the machine. NXCAM machine simulation verifies the programming and the material removal. Here we see NXCAM simulation verifying our 2.5D volume-based milling. We'll continue on with additional program features with easy-to-use 5-axis milling contouring around the bosses of our part. We then go in and we can look at swivel milling in 5-axis of the boss lugs on the part. We'll continue on with additional operations with 3+2 milling and multi-axis support by finish profiling the rest of our part contours, thus completing the first setup of this side of the part. Additional hole milling is fast and efficient in programming inside of NXCAM. Next, we'll look at the second setup. The programming begins here with face milling in the second operation. Cut and wrap or traverse across voids are all program options inside of NXCAM's toolpath. Material removal and verification is standard in NX. pocket floor and cleanup and helical Z-level wall machining is shown here. Here we'll continue on with that boss, finishing the second boss, and then moving on again to finishing the holes in the second operation of our part. Rotating and repositioning to do the second one with our spiral helical hole milling. Hole milling continues on the rest of our part to completing our part until we do our outside contour with multi-axis contour profiling. Let's look at how post-processing is done in NX. Here we select the desired post-processor in the desired control format. Quickly and efficiently, NX creates the posted output. Let's take a look at how this posted output next would be used in shop documentation. Shop documentation is standard in NX CAM, and we create HTML formats of each operation and operations sheet. Tooling sheets and operations sheets are also used in shop documentation. Again, a simple click and pick creates this documentation in seconds. The job is now ready to go to the shop floor. The part has been machined. Now it's time for the first article inspection process to begin. Let's look at what CMM programmer had completed while we were in the CNC department. You can see the inspection paths now have been selected and are completed. Any modifications made. We'll now go back and simulate what is happening on the shop floor inside of NX CMM. So here we'll see the inspection paths come down to the locations for our holes on the side of our part, and then we'll be deprobing our rib and pocket locations. Again, you can see safe repositioning of the probe to measure the rib locations and thickness. The manufacturer part is now complete. It passed inspection. You're in production now. All completed manufacturing cycles were done using NX. The wait, engineering change notice. How much time and effort will it cost you? Will there be to redo all the engineering and programming time on the first article production? ECOs with NX are an everyday challenge. It's simple, it's fast. We'll take a look at what has changed. We'll look at the hole locations, the rib locations, thickness, and corner blends all have changed. NX maintains the associativity of these updates and has updated all the documentation drawings and inspection drawings. The drawings you see have reflected all of these changes. Next, we'll review the impact the ECO has on the CNC programs. As you can see, we opened the part, and the part files in the navigator have been marked invalid. They need to be updated. Changes to the toolpaths were marked. We select generate, and the new processes are simply updated and used for your verification with simulation to approve their changes. We'll continue on looking at all these changes that are going on with our part. Next, the user will select and view the toolpaths of each maybe single operation he would like to review. We'll now look at what happened to the CMM program and verify those ECO changes. Again, we see the model has changed and the inspection paths. Again, we go back, use simulation to verify that, to have the confidence in knowing it was right the first time. Again, we will go back and see the pocket and the rib locations have moved along with the thickness. Fast, efficient ECO handling with NX Manufacturing Solutions. Okay, let's take a look at a little bit, you could say, as a review of what we could see of how the associativity, the digital thread throughout the manufacturing process really gets affected if we look at things that are going on more traditional today. In this example, we could say, which is really about time savings from an example like a change order that we had just seen. So if we look at that and say there had to be a modification maybe to the part or the fixture, you'd have to recalculate the tool path, re-verify your machining, update your shop docs, and then send this back out to the shop floor. So if we look at the amount of time that would take by doing this in separate systems, transferring data, finding data, and putting it back, each one of those represents a different time block for people's time. So if we look at that, what the typical work stoppage is for just one work stoppage, it makes me an average cost today between $200 and $300 for one short work stoppage of maybe 40 minutes of lost time in production to do that. And again, you can see if there were maybe 5 of these that occurred a week throughout your shop, this would be the kind of impact it would be maybe financially to that. It could be as much as $50,000 to $75,000 annually. Now here in this example of saying, looking at this as the digital twin, really at its effectivity of having all the associativity into all the other areas of the picture design, the documentation, the drawing, the process sheets, potentially even the CMM or inspection quality, if you have that equipment, would be that. By doing that, we have still the same work stoppage for the same issue that would have occurred to do that. But now the lost time really has been compressed and shrank because we didn't have to go find the information, open it up in another system, export it out, find the right documentation, produce the work packages with that. So now our work cost really becomes $40 to $60 of a work stoppage time to do that, which again, you can see it in 5 stoppages per week. This is a substantial savings over the previous one that may have been $50,000 to $75,000 a year. Maybe you're at $10,000 to $12,000 annually because you can just that quickly, as you've seen in that example in the video of how we could make that design change that quickly, update the documentation, and re-verify can literally happen in those number of minutes, thus saving you all that time for looking at documentation, using multiple systems, and really getting it right the first time when it goes to the shop floor. Next, we'll take a look at this in a different part, right? A part that really would require multiple setups between that. There's turning operations, there's secondary drilling, there's a third operation for milling, say in the tombstone. And again, maybe you wish to tie in your inspection. And again, how that could also be done and move quickly and easily into the mill turn environment if you so have them. They've become very popular today and there are many, many shops. So NX can really look at increasing the efficiency, right, in turning, milling, drilling, multi-axis, right, your CMM and documentation as we've seen. So, many of those products today need this kind of multiple setups. And again, let's take a look at how we can see the master model process with that. Going through that digital thread can do that to help us save time, make this more efficient for you in your shop. Complete programming of a machinery part will be demonstrated here. Here we'll take a look at this filter head part. We will start with the turning setup in NX CAM. Notice we have a workpiece setup. We define our workpiece, our stock, blank, and fixture components. Along with that, we will identify the blank, and we will select the materials from the material library that this part will be manufactured from. Here we'll select aluminum for our part. From there, we will go back. NX automatically creates the spun outline for the lathe cross sections that's used for programming. There we can see them outlined for us. Next, we'll look and see how to create toolpath operations in NX. So we can select. Here we'll take a look and use the facing operation for our part. We'll select our part, and it's as simple as just selecting the cut region or the cut face we wish to use. Again, we can grab the tool, dynamically zoom in, take a look at that, and simply press generate. At that point, we understand the volume and size of the stock. We created the facing operation. We'll create our second operation for roughing. Simply press generate. We understand where the stock volumes are, no additional picking necessary. Here we'll see 3D material removal and toolpath verification of the 2 toolpaths we have just programmed. We will continue on programming our part with the rest of our features, grooving, finish operations, etc. Here we'll take a look at what the programmer has done with that. We'll replay this again with verification with material removal. We see our facing operation, our OD operations, followed by we'll have our finish pass grooving cycles to complete our part, along with the boring or drilling of the large hole in the center of the part. Second machine setup is drilling. If this part was done in a conventional manner across 3 different machine tools. NX setup assures reliability with machining by the use of assemblies. Here we use feature-based machining to automatically program the holes of the part. Feature-based simply select the part and select the desired type of features we are looking for. You may filter them just separately or find all features on the part. Here, we will unselect grooves and we will just select the hole operations on the part in this demonstration. So with this, it's simple. We select the option for holes, and we ask it to find the holes. We see NX is finding the features, locating them. There we see that we have found over 60 features, or hole features, in our part. It is quick and easy to just select these features to have them automatically programmed with the appropriate tool size and operations for that feature type. Here we have our drilling operations, our spot drill operations, center drill, chamfering, and our tapping operations. Let's go ahead and take a look at the verification of these program operations. With this, we'll simulate the part, we'll zoom in, and we can see where our first position for our hole location will be. Then we will just select play to watch our program operations be simulated as they would be machined on the actual machine tool. We'll continue from spotting on to finish drilling in our operation, thus completing the second setup for this part path. We will continue on moving into our third setup, which really involves the finish machining operations on the head of the part. Here we're using horizontal machining with our multi-part programming. 2.5D volume-based milling keeps track of all the impressed stock across multiple machine parts. With NX, it is only necessary to machine or program one part, and all the other parts, regardless of orientation, are simultaneously or automatically machined. To make a change, it is quick and easy. It is just select the operation, double-click, and make the selected changes. Multi-part programming is standard in NX CAM. This would complete our standard machining operations of turning, drilling, and milling. Multifunction machines reduce setups and increase productivity. Multifunction programming requires only one setup in NX CAM. Here we see synchronized toolpath on the main spindle for turning the main body of our part. We continue on with the boring of our part, finish toolpath, and grooving operations. We will continue on by drilling on the main spindle and milling operations on the sub-spindle, continually programming on the end of our part, creating the part contours, relief areas, and holes on the head of the part, while we're still drilling 60 holes on the main spindle, thus saving valuable program and machine time across multiple machines. Here again, we can see is the toolpath verification, some chamfer milling operations going on. Now we'll finish the face milling on our part, moving on to do some 5-axis machining inside of the small cavity on the top of our part, all while still drilling our 60 holes. 5-axis milling, again, is simple and easy in NX CAM. Here we'll see our contour and contour profiling operations in that tapered wall cavity. There we have it, a 5-axis mill turn part, all completed inside of NX CAM multifunction machining. After completing the first part, we have moved to the finish inspection operation as we had seen before in our aerospace style part. So we see all of our inspection paths that we had selected, utilizing the same features of linking our PMI programming on the part. The CMM programmer may make some desired changes, as we've seen before, changing the size or number of points or contact points that are used. The easy-to-use interface allows quick, rapid changes inside of NX CMM, all with the power of NX, milling, drilling, turning operations. Whether standalone machines or multifunction, they're all done fast, efficient, and easily with NX CAM. NX CAM performance, it all starts with a 3D solid model, is the digital twin of that product that you're manufacturing. It all starts there with that start model of the machine part. What your shop can gain with NX CAM is one solution with all the applications a manufacturers need. Manage and adopt changes faster, tool control beyond the industry norm, feature-based machining and automation, G-code-driven simulation and verification, and of course, digital twin manufacturing technology. NXCAM offers the latest cutting strategies such as adaptive milling, which is the next generation high-speed roughing strategy. Ideal for cutting hard materials, adaptive milling enables deep cuts and consistent tool loads that increase material removal rates. With adaptive milling, you can significantly shorten your machining cycle while extending your tool life. Advanced finishing methods capable of machining good quality surfaces is important because it helps you minimize your rework, such as polishing. For example, the streamlined tool path follows the natural shape of the machine part that produces smooth flowing patterns with the finest finishes at high feed rates, resulting in a superior finish. Increasingly, machine shops employ multi-axis machining, especially in mold and die, which can minimize setups and improve overall productivity. With NX, you can automatically convert existing 3-axis tool paths into 5-axis tool paths, which lets you machine deep cavities using short tools to reduce chatter and improve quality of the machine molds and dies. With NX's wide range of capabilities of all the modules is what manufacturers like to have to program their jobs using one system. When it comes to NC programming, you need to check if the CAM system offers a range of functionalities that you need. Many successful companies standardize the NC programming by using one system, which gives them unique advantages such as a seamless programming process using the same data in the same software environment. That's how most of our customers leverage Siemens comprehensive CAM systems. They use NX CAM because it covers a wide range of NC programming capabilities, from 2.5-axis programming and turning to 5-axis milling and the latest multifunction machining.
This concludes today's webinar. Thank you so much for being here, everyone, and have a great day.